Welcome to Flash's Flatprinter 3. Today I'm going to give you a tour of all of the changes, mods, and the history of my Flatprinter 3 and what I have put on it and changed to make it into a machine that was up to my expectations. Now mind you, these are my views. This is my flat printer. So just keep all that in mind as you hear what I have to say. This is my forum and my views are unbiased, so you may hear different viewpoints that you may not hear on the forum. So to start the tour, one of the very first things that when I put my kit together that I recognized was something that needed to be on here were e-stop switches and power switches up front where the operator can gain access to them quickly. If this machine gets out of control, I want to be able to stop it quickly, and so that is the purpose of putting the red e-stop switch on the front of the machine where it's readily accessible. The black switch to the right of that is the power on-off switch for the machine, which will also shut it down quickly. And the yellow button to the right of that is the spindle power, which I can turn on, and the blue button is for the vacuum. Now I found after I got the machine together that I really preferred having the vacuum and the spindle tied together, so I'm not using the blue button for anything at the moment. From here you'll see some other things on the machine that didn't come with it. For one thing, I have a laminate router on my machine, which is a Bosch Pony laminate router, which is a step up, if you will, from the spindle that came with the machine. To give you an idea of what came with the machine, this was the original spindle and motor, and this motor generates a ton of noise through the brushes. Also, the spindle came apart very easily. As you can see, the threads that are on this spindle got to the point where they simply fall off. So if this part of your holder here was not tightened down very tight, this whole spindle could drop off. Also, the inside chuck mechanism was prone to fall out. So combined with the noise that the brushes were generating, I decided this had to go, and so this was one of the first things I wanted to put on the machine as soon as I could get to the point where I could do that. So I produced a template by taking measurements off of the existing template and ordered the Bosch router and put that on. Okay, if we go, let's take a little trip around to the inside of the machine, to the electronics door, bay, and let's take a look in here and see what we have. Let's see if we can get a little better light on the subject here. Okay, what you will notice here is I have a Planet CNC board, but this is a do-it-yourself version that John Bernard built for us that has the parallel port on a connector, so that we can easily switch between Mach 3 and the Planet CNC board very simply and very easily. Everything's all contained on the same circuit board. The software is the same software that everybody else is using, but the board is a different design. Currently this is not being used. I am running off of the parallel port for reasons which I'll go into in a few moments. You will also notice that on my machine I have a I've added the Mechatronics relay board, which is right here. The relay board is attached or wired into a socket on the back of the machine, where I can plug the power in for the switched output for the spindle and the switched output for the vacuum or light or whatever else I want to run from there. And I have thrown out the Mechatronics control board and replaced that with the Gecko G540 controller. Now on the Mechatronics board you adjust your current for your motor through an adjustable potentiometer on the circuit board, and then you have to adjust another pot to get out the harmonics and stuff. The Gecko has just one thing. It's a fixed resistor that we put on the stepper to control the current for the stepper motors. So if I want 1.2 amps, I put a 1.2K resistor there. If you take the resistor off, it's unlimited current and you burn things up. That's kind of the same thing that happens on the Mechatronic board if you were to turn the pot all the way open. This is our parallel port connector, which is now going around to my computer, which I had to revert back to a standard desktop computer, tower computer, so that I could run the parallel port due to the CNC software does not support backlash adjustment at the present time. It is disabled, and this machine has backlash, and it's a mechanical backlash that you cannot eliminate mechanically, and it required, at least on my machine, it required a software adjustment to get rid of the backlash to be able to produce circles that are actually circles and not oblong eggs. So I don't know if you can see in here this is our switch mechanism. You might be able to get a little better idea looking in here. The 4 toggle switches are wired in, and so we gain access to all of that through the electronics bay here. Okay, and along in the back here is my outlet for my switched power, and I have my switched power going through a surge protector which provides noise isolation, because when I first had the machine wired up, every time I would fire up the spindle motor, it would cause the Planet CNC software to lock up, which is another reason I'm now using Mach 3. Those are some of the things on the inside. One of the big problem with the machine was the fact that the rollers the pulleys were not centered, and the axles on the drive rollers had a lot of play in them, and we could not skew material. In other words, the material skewed as it moved in and out along the x-axis. So the bit would never return to the home position on some machines, and mine happened to be one of those. One of the things that I observed during the time that I've been working on it, when I was actually attempting to cut out some MDF, was that I was getting a lot of wear on the stepper pulley, and MDF was building up inside the very fine teeth that were on the stepper pulleys. And so I decided I wanted to go to larger pulleys with deeper teeth. So these, I don't know if you can see, but these teeth have about 2/10 of an inch depth, and it's a 3/8 inch wide belt. This will prevent the stepper motor from jumping teeth easily. They won't jump teeth, period. The motor will stall first. And so with that in mind, let's put this camera back up on the tripod, and I'm going to open up the top of the machine and let you see inside, because we got some more things to show you there. As you can see, I do not have this bolted down. Been in and out of it many times. What you're seeing here is a new guide rail system that I've installed, which is here to process balsa. So I've got 6-inch balsa strips that are 48 inches long, and I need them to track accurately across full 48 inches. And I found that the pressure rollers, if they're just slightly out of adjustment, will introduce skew, and I can't have any skew on the parts I want to cut. So what we have done here is added some T-nuts, and we've built these guide rails which are adjustable, and so now I can put, say, 3-inch or 2-inch balsa strips in here and actually get it to line properly. When I put these on and get ready to adjust them, I take an adjustable square and I just place it on the back of the machine, and now I can line up one of the guides and lock it in place, put my balsa in here, and then bring this one up to it and lock it in place. So now everything is square and I can cut accurately. Now I can take these guides off if I'm running sheet foam, and I don't need to have them in place. Okay, so now once we've got the machine opened up, let's go ahead and take a look at the rollers in a little bit more detail. Again, this is a different setup than what Mark and everyone has recommended. This is my own setting. As you can see, I have two of these lock collars on the right hand side here. This locks down the hex shaft just to make sure it's not going to move. My pulleys are I actually made a mistake ordering the pulleys. I got a 1.7-inch outside diameter, but the company where I bought these from, they measure the outside diameter as being where the grooves of the belt are, whereas other companies measure it as the outside edge of the pulley. So I should have ordered a 1.5-inch outside diameter, as it turns out, but these work just fine. I did have to sand them down a little bit to get them to get the ridges off the top so everything would fit into place, but I would do that a little differently if I were doing it over again. Of course, you know, we've done all the things about taking tie wraps and putting them in the hex shaft to get it to center up, and we've used JB Weld to lock everything down and lock it in place. As to the stepper motor that I am using, I don't know if you can tell for sure here, but this is a bigger stepper motor than the one that came with the unit. I found that it was very easy to stall the X-axis motor with these two big drive rollers. All you had to do is just put a little pressure on your material and the steppers would stall. So I've gone with a larger stepper here that provides a little more torque, and because I'm using the bigger diameter pulleys, I also get more torque as a result, because I have less number of steps per inch to drive the material, which gives me more torque. So that was a couple of the reasons why I went this direction versus the 1/4-inch belts that came with the machine. One of the other things that come about is adjusting these rollers is very critical. So I use a set of dial calipers, digital dial calipers, and I actually measure the distance from the top of the roller to my table on both ends to make sure that the rollers are the same height, and you can't really trust using these using the method that Mark has proposed, where you put two washers here, and two washers and two washers, and then you lock down the pressure rollers to the main drive rollers and adjust it that way. Doesn't really make these rollers come out flat with the table. There is enough of a difference there that I use the digital calipers method to set them, and I also added an additional adjustment over on the left hand side of the rollers. And what this allows me to do is to adjust the rollers in and out of parallel, so that I can make both of these rollers exactly the same distance apart from each other. I have a piece of MDF, if you can see it down on the bottom, which is used to adjust the height of the rollers, and I do that first. I adjust the height first and get it locked in place, and then I lock down one side. I make sure that that this roller here is the same distance from the front of the machine as the roller is from this side. There's that you really can't control too much. It's pretty well fixed by the width of this piece in here and the hole, but this was very close to start with, so I didn't really have any problem with that. But the problem I did have is that this distance here was not necessarily the same as the distance on the other end. So what we did is we added a skew adjustment here, where I can adjust the rollers in and out, and they sit on top of the piece that has established the height of the rollers. And now it is very simple to move the rollers, to move the adjustable roller, this one back here in the back, to move it forward and backwards and get it lined up precisely parallel with the front roller. So I think that is I believe that's all of the adjustments and modifications I've made to my machine. Again, I wasn't getting round circles, so I have had to resort to a different computer, which I didn't like having to do, but I ended up doing that. And I brought up Mach 3, and in Mach 3 you have a configuration setting for backlash, and you can actually measure the backlash on this machine, and mine measures 24 thousandths. I expect most of the machines are going to be very, very close to that. You have to change the backlash speed percent of max to 100%, enable backlash, and then you have to go into the configuration, where was that, general config, and you go over here to parameter called shuttle acceleration, and you make that 0.005 seconds. That turns on backlash compensation, and now I get perfect circles, and you can hear the backlash being taken out of the machine when it goes when the rollers reverse direction from one direction to the other. You'll hear it go snap as the backlash is taken out. So now I have my machine cutting probably as accurately as one can ever expect. It's down to the thousandths of an inch accuracy, and it is performing to my expectations, and I'm very happy with it. It took a month and a half of daily working with the machine to get it to this point, so it wasn't simple, but I have learned a whole lot about CNC in the process, and that's what the hobby's all about. It's about learning CNC, as well as having a machine that has a small footprint that you can cut foam with, You can cut like balsa wood, plywood, and if you notice my stock of material over here, you can see that I have cut out a considerable amount of MDF as well as balsa. So I think this is going to be a fine machine. Now that I've got it up and running, I'm very happy with it. But I wanted to let everyone see some of the things that it took to get this machine to the point where it is now. So thank you for watching, and if you buy a flat printer, remember there are a lot of mods that you can do on your own, and you know, you may be happy with it as the way it comes from the factory with no modifications whatsoever. If you're just cutting foam planes out of 1/4 inch fan fold foam, you probably could care less about some of the features and things that I have done on my machine. Again, I had a flat printer, well, it was called an MK1, which I modified to an MK 1.5, and I've had that for a couple of years, and so I've kind of grown out of just cutting foam planes. This was a step up for me. I wanted to be able to cut more than just balsa, or just more than just planes. I wanted to cut balsa, ribs, and I want to be able to cut some woods, some light woods. The MDF is a very easy material to cut. You use the multi-pass option that comes with the SketchUp plugins, and you know, as long as you take it slow, you know, there's no reason why you couldn't you know, cut those kinds of materials. The laminate router, of course, allows me the capability to cut 30,000, actually 35,000 RPM spindle versus the 15,000 RPM spindle that came with it, and I can put a 1/4 inch bit in it, and I can probably do a little more serious cutting with it, although probably it's going to be the standard 1/8 inch bits that I've been using. I have some 1/32 bits which are just perfect for doing the foam or the balsa wood cuts, and also some of the 3mm Depron, 1mm Depron. That bit is excellent for doing those kinds of cuts. So anyhow, I thank you for watching, and this concludes my my video, and stay tuned, check in on my my blog every now and then, and we'll show you what things we're going to create with it in the future.